Mount Etna is flaring up again, but this time something is emerging from within the volcano, leaving scientists puzzled. It's not just lava, but a glowing material with a distinctly different character. The material appears to be erupting, emitting light amid the crater's activity. The question arises, what exactly is moving from Etna's depths? In this scenario, observers note the material has an unusual color and texture compared to typical Etna lava. Its appearance is considered distinctive enough to attract attention and prompt further investigation. Samples are then supposedly taken to a laboratory for in-depth analysis. However, the further the investigation, the greater the mystery surrounding the material. Initial analysis in this narrative suggests that the material cannot easily be classified as basalt, andesite, or any other common volcanic material. However, such findings cannot be considered fact without verified laboratory evidence. If such characteristics are confirmed, the material could provide clues to more complex magmatic processes. Etna may be revealing parts of a previously hidden underground system. To understand this possibility, the journey must begin deep beneath the crater, where magma moves through a network of superheated rocks. Magma carries heat, gases, crystals, and various chemical elements from the Earth's depths to the surface. Under certain conditions, mantle material can interact with the crust it passes through. Mixing, crystallization, and differentiation can change the magma's character before it finally reaches the surface. When pressure and magma supply change, Etna's activity can develop into a paroxysm, a very intense eruptive phase. Eruption columns can rise, lava erupts from the crater, and hot fragments move down the slopes. Under certain conditions, pyroclastic flows can move very quickly and pose a serious threat. However, any figures regarding their speed and impact must be based on thoroughly verified observations. Behind the fiery spectacle lies a much more difficult question to discern: the stability of Mount Etna's body. Magma movement, internal pressure, fractures, and slope deformation provide important clues for volcanologists. All these changes help scientists determine whether Etna is still following its usual pattern of activity. Because the surface of a mountain can appear calm while the system beneath it is constantly changing. Etna also has a geological history that is much older than human civilization. The mountain has experienced major changes, including sector collapses or flank collapses in the past that displaced large amounts of material towards the sea. Such events demonstrate that volcanic slopes can experience large-scale instability. If a major collapse occurred on the coast or under the sea, the mass movement could theoretically trigger a tsunami in the Mediterranean. However, history is not predictive. Etna's current activity does not automatically mean the volcano is heading for a major collapse or tsunami. For this reason, small earthquakes, surface changes, gas emissions, and magma movement are crucial to monitor. Scientists combine all these signs to understand whether Etna's system is changing or simply undergoing a normal volcanic cycle. The biggest question still hangs over Sicily. Does the unusual incandescent material, if confirmed, signal a change in Etna's magma system? Or is the phenomenon simply part of a complex volcanic cycle and still within normal limits? For now, the best scientific answer is to wait for testable and verifiable evidence. Because in the world of volcanoes, something that seems extraordinary isn't necessarily unprecedented. As the red glory appears from Etna's crater, the camera seems to slowly move into the darkness below. There, heat, pressure, rock, and magma continue to interact unobservable. Each eruption is merely a brief message from a hidden world that still holds many questions. It's not just what's erupting from Etna, but what's actually changing deep beneath our feet.